Hey guys, Pekin here. Imagine you're given a bunch of numbers and you want to try and create as many square numbers as possible by increasing all of the numbers by the same positive integer. What is the maximum number of squares you can make this way? Well, it's quite hard to see where to start with this problem, and there are many ways that would be the wrong approach to take. But the first thing you should consider is, when you do add a positive integer to all of the numbers to get the most number of squares, what do the numbers look like? Let's choose a random subset of numbers that will be squares in the optimal solution. What do the numbers look like? What form do they take? Well, say we added an integer k to all of the numbers. Then, originally, these chosen numbers that are squares after the operation must have been in the form of some square number minus k. Now realize that because of this, the difference of any of these two special numbers or these two chosen numbers will be the difference of two squares, because the added integer k cancels out when you minus them. This means that if we consider two elements, say a and b, such that b is greater than a and b minus a equals some difference of squares, say y squared and x squared, then a and b can be represented as x squared minus k and y squared minus k respectively, because the difference is still y squared minus x squared and we can just adjust k. Note, however, that you do want y squared to be larger than b and you want x squared to be larger than a, so that k does not have to be negative. This means that we can add k to both integers and make them both squares. Great, now we can solve for two integers, but how about 50, like in the question? Well, we try something similar. We first sort the array in ascending order, and we fix an element, say the first element, and that element is the first square number in the array after the operation. We can now take the difference of it and all the other elements to the right of it. If you can represent all of those differences as the difference of squares, and the smallest square of all of those differences of squares is the same, for example, if you could represent the differences as, say, y squared minus x squared and z squared minus x squared, and so on, because the smallest square corresponds to the fixed element, we can represent the numbers as x squared minus k for the fixed element, and then y squared minus k, and z squared minus k, and so on. This means that we can add k to all of these numbers and create many square numbers. Now, this seems like a solution, except there is one problem. For this to work, we need to find all pairs of square numbers whose difference is the differences we got previously, because we want to find pairs of square numbers so that the smallest is all the same and their difference is the difference that we have. So for this to work, we can do a little math. Consider d equals x squared minus y squared. We know from school that difference of squares, x squared minus y squared, equals x plus y times x minus y. This means that there are two factors such that the average is x and the range is 2y. Now we can run an algorithm to find all pairs of factors of d in O square root n time. After doing this, we can check if the sum of the two numbers in the factor pair are even, and if so, that means that x can be represented as the average of the two, and y is the difference between the average and the other two factors. After doing this, we can store the square, the smallest square, which corresponds to the fixed element, into some map, and count which square has the most elements that can represent it, which will be the maximum solution for that fixed element. Then, we can loop through all the fixed elements and find the solution. Thank you for listening, and I hope you enjoyed the solution. Stay tuned for more interesting and cool videos.